Here we're going to do some work on redox reactions. So redox itself, red for reduction, ox for oxidation. So we just need to define what those terms mean first. So oxidation, the simplest way to think of oxidation is a gain in oxygen. So if something gains oxygen, it's an oxidation reaction. To think about reduction, it is a loss in oxygen. So you can talk about something being reduced if it loses oxygen. Now, as well as talking about oxygen, you can talk about oxidation and reduction in terms of electrons. So oxidation is the loss of electrons, whereas reduction is a gain in electrons. So don't get these two confused. Loss and gain, again, you've got gain and loss with oxygen and electrons. The easy way to remember this is with the mnemonic. So the mnemonic is oil rig, and this means oxidation is loss, reduction is gain of electrons. So in terms of electrons, you use oil rig. In terms of oxygen, you just think of, well, oxidation is gaining oxygen. So keeping those definitions there, now we're going to do some examples. So we'll start off with some simple examples, just talking about oxygen. So let's say we start with carbon, and we react carbon in oxygen, so we burn it, and it will form carbon dioxide or carbon monoxide. But the key idea here is that what we've done is the carbon has gained oxygen. So therefore the carbon has been oxidized. Or this is an oxidation reaction. You can say either one. Different example. Let's say we start with iron and we burn it in oxygen. It will form iron oxide. Again, the iron has gained oxygen. You can see from there that it's gained in oxygen, so the iron has been oxidized. Now iron turning to iron oxide, that's actually rusting. So rusting is an example of an oxidation reaction. So an example of reduction and loss of oxygen, you may have copper oxide. If you reduce it, then you would just form copper and water. So in this example, it starts off as copper oxide, this reactant, and then turns into copper. So overall, it's lost oxygen. Therefore, reduction is happening here. The copper oxide has been reduced to copper. So what we're going to do now is look at oxidation and reduction in terms of electrons. So this is where it gets a lot harder, moving on to kind of higher tier stuff. And to really understand this, you need to understand ions, ionic bonding. So if you haven't got a really good grasp of ionic bonding and what an ion is, can you go back, study that first, and then build on it with this. So let's move on to with electrons. Let's start with magnesium 2+, and when it reacts, it turns into magnesium. So we need to understand what this is trying to say. Well, magnesium 2+ is magnesium, but it's lost 2 electrons. So it normally has 12 electrons. So this is magnesium 2+. It did have a third shell with 2 electrons on the outside, but it's lost them. Now when it reacts, it turns into the normal atom of magnesium with 12 protons and 12 electrons. So now the magnesium will look like this. Okay, it's got no overall charge here. There's 0 charge. So if there's no charge, it's saying that the protons and the electrons are equal. So what has happened to make it go from magnesium 2 plus to magnesium 0, or normal magnesium? Well, for that to happen, this magnesium had to gain 2 electrons. Electrons are negative. So to send it from 2 plus back to neutral, you would have to gain 2 negative electrons. Gaining electrons we call reduction. So for this, magnesium 2 plus has undergone reduction to form magnesium. An example of oxidation using the idea of electrons, so oil rig oxidation is loss of electrons. If we started with the fluorine ion, so fluorine's got 9 protons, 9 electrons, but as an ion, it's gained a negative electron. So this is fluorine negative. If we draw it, it would look like this. 1, 2, 3, 4, 5, 6. This is normal fluorine, it's in group 7, but it's gained an extra electron, so now it's fluorine negative. And it reacts to form elemental fluorine with no charge. So for that to happen, it would have to become this. Normal fluorine in group 7 just looks like that. So for this to happen, this fluorine must have lost 1 electron. It's negative here. Here's the negative, and now it's not got any charge. Okay, it's got 1 more negative than it does here. So it's lost that negative. Therefore now positives and negatives are balanced, the charges are equal. Now this isn't quite right because fluorine doesn't exist as just fluorine on its own. It exists as in a pair as a covalent bond. So fluorine actually goes around bonded together like this. So for that to happen, this then doesn't really balance, so I would just then have to put a big 2 there. So overall, it will have lost 2 electrons. The idea, though, is what we're trying to show is if it's lost electrons, loss of electrons is oxidation. So the key point is that if we're going from negative here, overall to no charge, it's lost an electron, therefore it is oxidation happening here.